In this exercise, we're going to look at example number 2. In this example, we want to test whether the average horsepower of all the automobiles manufactured in the 5 countries is equal to 100 or not. So once again, the first step is to set up the hypothesis. We need to first define what mu is. So mu is equal to the average horsepower of all the automobiles manufactured by the 5 countries. Now, of course, we want to change this m into a mu, so highlight m and change the font to symbol font, and that will change m into a mu. So given mu is the average horsepower of the automobiles, we want to test whether that mu is equal to 100. Put the 100 in a separate cell. And mu not equal to 100, a not equal to symbol can be inserted by clicking insert, symbol, and look for not equal to. Here I have it right there, so not equal to. Now the alpha, once again, we'll assume the default value of 5%. Okay, now we'll get the summary statistics from the sample. So sample size is count of horsepower, x bar is average of horsepower, and standard deviation of sample, stdev.s, of horsepower. Let's format these two numbers a little bit. Now, standard error is s over square root of n. Then we can calculate the value of t statistic using this formula. So that will be x bar minus mu sub 0 is the value of mu in the hypothesis. So it will be that divided by standard error. Now the degrees of freedom is n minus 1. So let's format the t value. This is a two-tailed test because it is not equal to in the alternative hypothesis. So we need to, for p-value, the formula is t dot dist dot 2t, two-tailed test. Okay. And again, we'll use the absolute value of t, comma, degrees of freedom. So that will give us the p-value. Then the conclusion is, since the p-value is greater than 5%, it's too much error probability. So we cannot, so do not reject 8 sub O. And now we have to provide an interpretation. There are two parts to the interpretation. First part is the conclusion, and that will be, we do not have sufficient sample evidence to conclude that the average horsepower of automobiles manufactured in the 5 countries is different from 100. So that's the conclusion part. And the p-value part is that if we concluded that it was different from 100, then the probability this conclusion is wrong is 68.8%. That's too high a probability that we want to risk making that conclusion. That's why that conclusion, that is mu is not 100, is not sustainable. So let's now format it, and we are done. Okay, now let's do the same test using the t-table value approach and not the p-value approach. So here we need to get the t-table value. So we look at the alternative hypothesis, which is not equal to, and therefore if you look at the Word document, it shows you if it is not equal to, then we need to use t.inv.2t function. So this will be t.inv.2t, and the probability is the alpha value. Okay, and this will always give you the upper half of the t-table, and then the degrees of freedom is n-1, which we have here. Okay, so that's our t-table value, and now we compare the t-table value, okay, with the t-calculated value, and t-calculated value being less than t-table value, then we cannot reject the null hypothesis. And obviously we come to the same conclusion, we have to, but this is a t-table, this is the t-table approach as opposed to the p-value approach. So the conclusion is, since the calculated t-value, t-calc, that is 0.4, is less than the t-table value, do not reject 8 above.